Good morning, ninth grade class. Are you about tired of doing 2 lessons a day? Well, I hope you're only doing 1 lesson a day, but maybe you're tired of having me explain 2 lessons every day. After Friday, then you'll be back on schedule again of just 1 lesson a day is all that I will explain for next week. So, today we'll do 13 and 14. And then Friday you'll do 15 and test. And by the way, Cody, I see your test is still down in the gym. So please don't do it before you pick it up. Yes, lesson 13 has to do with functions. And functions is when you have a graph and you have different numbers or different points on the graph and you draw a line through it however you want to do. They have their relation. A function is what today we're going to decide which is a function and which is not a function. So if you have 3 and 2, you know that the first number is x and the second one is your y. You've done these all year, so that's pretty clear. So you can graph 3 and 2, you can graph 2 and 4, and you can graph 1 and 3, and that's a proper function. If you look on the first page there, it talks about functions never pair the same x value with 2 different y values. Okay, so what it's saying is it's not a proper way to write to have a 3 and a 2 together, and then let's say we put a 3 here. The x can never be paired with a different number than what it has in one of the sets. And you can have as many sets as you want. So you cannot have, this is not a function, when you have a 3 compared with a 2, and then the next one you have a 3 compared with a 4. You cannot do that. Or if you come back here, let me just say here, let's say for instance, I would make a 3 compared with a 2, and you say it's not proper. You could compare a 3 with, you could have another 2 if you, let's reverse this back up here again. Let's make this here a 4 and a 2. You can have 2 y's with the same number and be a proper function, but not you cannot have 2 x's with the same. So if you read the instructions, specifically on the first part, if you want to decide if a group of functions, if they're a function, check the first number. If the first number at any time, like the 3 is compared with a 2, you can't have another 3 in the first block compared with a different y value. Or it's not a function. Now, if you have it graphed, you haven't seen many graphs like this, but if you look at your example B, you have some graphs that do like this. If you want to check if this graph is a proper function or not, what you need to do is draw a straight vertical line. Anywhere on this graph, you draw a straight vertical line, and if you can cross your diagram 2 times, it is not a function. So this would not, the brown circle I made is not a function. Not. But this one here that I have here that's purple, if I draw a straight line through there, I can do it anywhere on the graph, a straight line, and it will not cross my other line twice. Then it's a function. So if you look at your examples, let's just go to number 1 and just look down through there. The first one is 9, 3, 8, 4, 3, 7, 7, 3. Okay, so what you go through and you look at the very first number is 9. Are there any other 9s in the x space or in the first number? No. Okay, you look at the 8. Are there any 8s in there? No. Are there any 3s? Yeah, go to the third one, 3 and 7. Now look at the 3. Are there any other 3s? No. And then the last one is 7. Are there any other 7s? No. So that means yes, number 1 is a function. Let's do number 3. I'll just drop right straight down to number 3. You have 1b, 3f, 2a, and 4h, and 3g. Now the question is this a function? So look at your first one. You have a 1. Are there any other ones? No. Are there any other? Then you go to 3. Okay, the second one is 3f. Are there any other 3's? Yes. Way at the end you have 3 with a g. This cannot be. You cannot have two x's that are the same grafted to a different y. The first one is 3f and the last one is 3g. So your number 3 answer is no. That one is not a function. Since we're going just straight on down, let's go to number 5. You have a circle. Now don't ask me what for figures they got to make that circle, but that was their circle. So let's check and see if this one is a vertical. I draw a vertical line through there and see if it's a function. Well, duh. I can easily cross 2 by drawing an upright line anywhere, straight one. I can't draw it on an angle, just draw it straight. I can cross the top of the circle and I can cross the bottom of the circle in numerous places across there. No. Number 5, no, it's not a function. Yeah, that's all I'm going to do for 3:13. Let me push over to 3:14. is dividing larger polynomials. Polynomials, if I can say the word right. Let me see here where to start. Well, let me tell you this. On this lesson is no different than what you have learned in previous lessons in dividing them. I think probably the biggest thing is they're just making them bigger. You'll have remainders, some come out even. So it's really not teaching you anything new more than it's just making the problem larger. Yeah, I worked out the examples. You got just example 1 on the first page and example 2 on the next page. So you find the mistake. There is a mistake in my book. When they were working out the problem, they copied or they worked one down. So if you go down through there and you follow the steps they made, now this is a trick here, listen, or this is a bonus. If you can find the mistake and text me, the only thing you have to do is just simply text me the number that's wrong. If you text me the number that's wrong, in the examples, I will allow you to skip one of the first part. Okay, in the first part there in today's lesson, you have 4 problems. I will allow you to skip one of those problems. Now look here, I put 2 on the board, and if you can find the mistake in the example in your book and text me that number, I will allow you to skip one of the other problems. Wow, you can't beat that, can you? That's better than being at school. So let me start out with number 1 and walk you through these steps. Number 1 is x negative 1 divided into x cubed, negative 3x squared, positive 3x, negative 1. And let me just put some parameters in place here. Anytime you keep adding on to the front, you have more exponents. So if you look here, we put an extra number here, and that's actually x3 to the 3rd value. So when I get ready to start out, I ask the question, how many times will x go into x? Well, I put the answer here already, so I'm sorry. How many times this is 1x, okay? You have to think of 1 in front. So how many times what will go into 1? Well, 1 will go into 1. Now look what I did here. This is where it doesn't matter how big you are, you will need to put the same exponent for the variable. So this one here, you just move it straight up, x squared. So this is 1, we'll go into 1 time. So x squared times x makes you 1x cubed. You see, let me think how to say this. You have 2 x's here and you have 1x here, so that makes you the x3. And now multiply 1 times 1, this is a positive times a negative, leaves you with 1 negative. And so I subtract, so that changes my sign here to a positive sign. And now I'll put the 1 here to help us out. 1, subtract, opposite signs mean you subtract, so that leaves you with a negative 2x. Okay, now you see that negative 2 is very important because it makes me a negative there. How many times does 1 go into 2? 2. Okay, but you see I have a positive 1 into a negative 2 makes me negative 2. You got that? You have to have a negative here because I wound up with a negative. Again, just move the x straight up. Don't fret about that part there. If you keep your chart straight and your numbers straight above where they're supposed to be, this is 2x, negative 2x. So now you're ready to multiply. Negative 2 times 1 is going to be 2. But look, 2 negatives make you a positive 2. Oh, I forgot. I brought down my 3x here. Just my positive 3x. So now I got a positive 2x. And then I just go 2 times 1 is 2. And I had an x here. An x here makes me x squared. And that's a negative and a positive makes me a negative 2. Now I'm ready to subtract this here. And again, if you look closely, I will need to change this here to the opposite term. So I have a negative 2. I'm subtracting negative 2 from positive 3. I come up with 1 positive. And of course here, that there erases that one. So 1x, I bring down 1. My negative 1. And so then you ask yourself, how many times will 1 go into 1? 1 time. And now you multiply 1 times 1 is 1, and 1 times x is x. Let's erase this 1 because that's improper. You subtract, this problem came out right. Or come out even. There was no remainder. The next one I did was number 3. They put it in a fraction form, which is no different. The bottom one is your divisor, and the top one is your dividend. So it's 2x negative 1. Let me see how to do this. I'm going to go, how many times does 2 go into 6? It's 3 times. So I go 3 times 1 is 3. I'm going to skip the x's here. I'm going to speed up a little bit. 3 times 2 is 6. And now I subtract. So this actually changes this one to a positive number. And you know that when you have a positive, the rule is like signs add and use that sign. So 5 plus 3 is 8, and it would be a positive. And now I'm bringing down my negative 15, and I ask, how many 2's will go into 8? I said 4. 4 times 1 is 4. Now I did a negative there, and 4 times 2 is 8. I'm ready to subtract, and I need to change the subtract hand. By the way, did you know that I'm changing this here every time as well? This is supposed to be a negative now, but because it's the same, I just always just wipe it off. But a negative 8 from a positive 8 makes you 0. And right here, I should have went 0 here as well. That's something that I just skipped because it just understood. Now I have a positive 4 and a negative 15. Opposite terms means subtract 4 from 15 makes me 11. And I use the biggest sign, 11 negative. 11 negative, bring down my last term, positive 6. And I ask the question, how many times will 2 go into 11? 5. I go 10 times, but yeah, 5. Now look what you have though. I have a positive 2 and a negative 11. Get this, you must put a negative back up here again. So 5 times 1, both negative answers, makes you a positive 5. 5 times 2 makes you 10. And because you are opposite signs, it's a negative 10. And now I change this here to I have a negative 5 and a positive 10. And I'm ready to subtract my problems. Negative from 5 makes me 1 positive. I subtract 5 from 6 makes me 1 positive. And 10 from 11 makes me 1x. I use the biggest sign, negative, leave the 1 off. My remainder is x plus 1, or negative x plus 1. Negative x plus 1. That's number 3. Let me tell you about number 9. Number 9 is a problem like we did yesterday, but the line is vertical. And you say, oh, if I draw a vertical line, will I cross that anywhere? And the answer is yes, you will. So number 9 cannot be a function. Thank you.